In this video, we're going to discuss geometric sequences. A sequence is basically just a list of numbers. Let's say 2, 4, 8, 16, 32, ... A geometric sequence is a list of numbers that each term in the sequence is the term before it multiplied by something. And between each term, we're multiplying the same thing. To find a term, we're multiplying the term before it by 2. So to find 4, we're doing 2 times 2. To find 8, we're doing 4 times 2. To find 16, we're doing 8 times 2. To find 32, we're doing 16 times 2. And we could also be multiplying by a fraction. So let's say we would have a sequence 84, 42, 21, ... What we're multiplying by in this sequence, we're multiplying by a half. Each term, we're multiplying it by a half to find the term after it. This thing that we're multiplying by, either in the first one it would be by 2, in the second one it's by a half. This term that we're multiplying by is called the common ratio. When we have a geometric sequence, each term is in a specific position. The first position is called a sub 1, the second position is called a sub 2, the third position is called a sub 3, and there are different ways we could write out a geometric sequence, so we could find specific values in a geometric sequence. The first way is recursively. The recursive definition of a geometric sequence is a sub n is equal to a sub n minus 1 times r, where r is the common ratio, a sub n minus 1 is the term before the term that we're solving for, and a sub n is the term that we're solving for. And we have to be given a sub 1, which is the first term. So let's say we would have a recursive sequence, a recursive geometric sequence. A sub n is equal to a sub n minus 1 times 3, given that a sub 1 is equal to 2. So let's write out the first 3 terms in our sequence. A sub 1, we're given, is 2. A sub 2, the second term in our sequence, let's solve for a sub 2. To solve for a sub 2, we're doing a sub n. N is the place value of our term. So in this case, it would be 2. This is the second term in our sequence. So a sub 2 is equal to a sub n we're plugging in as 2, 2 minus 1 times 3. And a sub 2 is a sub 1 times 3. A sub 1, we already know, is 2. 2 times 3. So a sub 2 is equal to 6. And now let's solve for a sub 3. A sub 3 is a sub 3 minus 1 times 3. So a sub 3 is a sub 2 times 3. A sub 2 we already know is 6, so 6 times 3 is 18. And these are the first 3 terms in our sequence. And notice that our common ratio is 3. We multiplied 2 by 3 to get to 6, 6 by 3 to get to 18. If we wanted to continue going to find a sub 4, we could do 18 times 3, which is 54. And we could keep on going in our sequence. The problem with using a recursive definition of a geometric sequence or even an arithmetic sequence is, let's say we wanted to find a sub 20. Let's say we want to know what is a sub 20. So a sub 20 is equal to a sub 20 minus 1 times 3. So a sub 20 is equal to a sub 19 times 3. The problem is we don't know what a sub 19 is. Let's say we would try to solve for a sub 19. A sub 19 is equal to a sub 19 minus 1 times 3. A sub 19 is equal to a sub 18 times 3. But we don't know what a sub 18 is. That's the problem with a recursive definition of a sequence, is that we need the term before the term that we're solving for in order to be able to find what the term that we're solving for is. So another way we could define our geometric sequence is with an explicit definition. The explicit definition of a geometric sequence is a sub n is equal to a sub 1 times r to to the n minus 1. You do not need to memorize this. It's on the formula sheet on the Regent. So a sub n is the term that we're solving for. A sub 1 is the first term in the sequence. R is the common ratio, and n is the place value of the term that we're solving for. So let's say we have a sequence a sub n is equal to 3 times 2 to the n minus 1. And we want to find the 17th term. So we want to find a sub 17. A sub 17 is equal to 3 times 2. So wherever we see an n, we're plugging in as 17 to the 17 minus 1. So we're doing a sub 17 is equal to 3 times 2 to the 16. You cannot multiply 3 by 2 because you first have to do the exponent. You have to do this in the order of PEMDAS. So you first have to do the 2 to its exponent, and then you can multiply by 3. You can't do 6 to the 16. You first have to do 2 to the 16 and then multiply by 3. So you could do this on your calculator if you want. 3 times 2 to the 16 is 196608. That is the value of this term. If we had wanted to find this using a recursive formula, the recursive definition of the geometric sequence, we would have had to find a sub 15, a sub 14, a sub 13, all the way back down to a sub 1. On the Regent, you might be given a scenario and told to write either a recursive definition and or an explicit definition for that scenario. Let's say you're given a scenario where the first term of a sequence is 2 and the common ratio is 1/3. So each term you're multiplying by 1/3 to get the term after it. So let's say we wanted to write a recursive definition of this sequence. The recursive definition of any geometric sequence is a sub n is equal to a sub n minus 1 times r. This you will have to memorize because it's not on the formula sheet, given a sub 1. So to write, if we were writing out our sequence that we have, a sub n is equal to a sub n minus 1 times r. The common ratio is 1/3. Given a sub 1 is equal to 2, and this would be your recursive formula. Let's say you were asked to find the explicit formula. The explicit formula you do not need to memorize because it is on the formula sheet, and that is a sub n is equal to a sub 1 times r to the n minus 1. And we're going to plug in what we know. A sub n is equal to a sub 1, the first term we know is 2, times r, the common ratio we know is 1/3, to the n minus 1, and this would be your explicit formula. Another important thing to be able to recognize is on the Regent there's another way to write these recursive and explicit formulas. Instead of writing for the recursive formula, a sub n is equal to a sub n minus 1 times r given a sub 1, you could write this as f of x is equal to f of x minus 1 times r given f of 1. That means the exact same thing. F of x minus 1 means the term before it, r is still the common ratio, and f of x is what we're solving for. It means the same thing as a sub n. The explicit definition is a sub n is equal to a sub 1 times r to the n minus 1. You could also write this as f of x is equal to f of 1 times r to the x minus 1.